Fractions, a stumbling block for lots and lots of people. If you understand fractions, you're probably going to think that I'm just rambling, and I probably would tend to agree with you. But if you don't understand fractions, you're probably going to think I'm rambling, and it's all Greek to you. It just, what is he talking about? Where those who understand fractions will just go, yeah, I get it, okay, move on, I get it. Those who don't understand fractions just look at you kind of cockeyed and go, I don't know what you're talking about. I don't know what you're saying a lot of words, but I don't know what you're talking about. So this is for the people who don't understand that well. But at the same time, towards the end, I'm going to do a couple exercises, and I do think that I should be able to challenge your envelope of understanding no matter how well you understand fractions. And if I can't challenge your envelope of understanding, then you don't need to watch this video. So people who have a hard time with fractions many times think they're inept or not capable of understanding, or they're just not going to get it. And that happens for a variety of reasons, and it's not necessarily your fault. Maybe it is your fault. You're the only one who knows how hard you've really tried. It may not be your fault, but it is your problem, and nobody can solve that problem for you but you. Not a tutor, not your parents, not your teacher, not your friends. Nobody can solve that problem for you but you. So you've got work to do. You actually have to sit down and do it. You need to actually think and figure out what's going on. So that's entirely up to you. You're the one that has to make it happen. You're going to solve that problem if you work at it. If you don't work at it, it's just not going to get solved. So it really is up to you. You've got to do it. It's hard to say this, but I mean, it's hard to say it so that it makes sense. But you don't need a tutor. If you don't understand fractions, I think there's very little that a tutor can do. What you need to do is practice. Practice. And there's also, I don't want to say there's no concept in understanding fractions, because there's lots of concept, but there's no concept that can really be taught. Until you do understand fractions, then you can be introduced to new concepts. But those initial concepts to understand fractions, those have to be arrived at on your own. And I really don't know how that happens, or when it happens, or where it happens, but I do know that it does happen. So what happens is that, the concept just emerges somehow. It emerges during the process of doing exercise after exercise after exercise. So I would try to explain it the human mind is very, very good at recognizing patterns. So you recognize patterns, all the time. You see this, and then you expect this to happen. You expect that to happen. With fractions, the human mind's doing the same thing, but it's trying to recognize patterns, but you're like grasping at straws all the time, until you gain an understanding. You're grasping at straws, and you go, oh, it works like this. And then you know that, oh, it doesn't work like that. So how the heck does it work? And then you're grasping at straw. And sooner or later, you grasp at straws that make sense. And you notice that those make sense. You apply it to different problems, and it still works. So that solidifies those straws in your mind, and the concept just emerges somehow. But in order to get that concept to emerge, you have to practice. There's just no substitute for practice. Right. And I'm not affiliated with Kumon Math Center at all, not one iota. But from what I understand, at Kumon, they just do exercises. It's meant for younger kids, and they just do arithmetic exercises over and over and over again. And if that's true, I think that's, if you don't understand fractions or arithmetic, or you're just having trouble with math in general, that's really what you need to do. You need to just sit there and do problem after problem after problem. And then I think what happens is you notice something, or you're doing a new problem and you notice it's kind of like the old problem. Maybe you're simplifying a fraction and you notice that both the numerator and the denominator are twice as much as they were in a previous problem. And you also notice that the result is the same. So you start scratching your head and going, whoa, that's weird. Why did that happen? And you look at the old problem and the new problem, and you look and you notice that, yeah, they are the same because, well, this might take a little time to understand, but they are the same because the numerator and denominator are both twice as big as the other problem. And you can just divide numerator and denominator by 2, and it reduces to the former problem. So, and when you recognize something like that, I think concept is emerging in your head. You're like, oh, and then, and we stick with we notice these patterns, we stick with the patterns that work, and the patterns that don't work, when it's demonstrated that that pattern's not going to work, we discard it and go, oh, I thought that was going to be useful, but I guess it's not, so I'm not going to think that anymore. So the trick, it's not a trick, but the method to understanding is to keep pounding away at it. Keep doing problem after problem after problem, and the concept will emerge. I guarantee it. It's going to happen. There's very little that a tutor can do if you don't understand fractions. I mean, a tutor certainly can help you understand, or help get your understanding started, but you quickly run into a roadblock if you aren't ready, if that concept isn't going to emerge in your head. If that concept, it's just a roadblock. If you've ever tried to explain something to somebody else, to a friend or brother or sister or parent to child, and you recognize that lack of understanding, or that they aren't understanding whoever you're explaining it to, and it's just a roadblock. I mean, you recognize that it's just not going to happen, that the person isn't aware enough or hasn't got the foundation, just isn't ready. And we're first introduced to, we do fractions and arithmetic, then we do ratios and proportions. That's our first, I think, introduction to what you could argue is abstract concept. When you're explaining something to somebody and it's very basic, there's nothing else, you can't move forward in the material until they understand it, and they're not ready to understand fractions, the efficacy of the tutoring session is diminished to almost nothing. You end up just sitting there and everybody's frustrated. Certainly I'm frustrated because I want to be effective. I want to earn my money, and I don't think I'm earning it if I'm unable to get the point across. And I understand there's more than one way to get the point across, and I do try different methods, but there are times when it's just not going to happen. So that's why I say, at this level, I don't think you need a tutor. I don't think you need a tutor for arithmetic. I don't think you need multiplication, long division, all that stuff. You just need to practice. You just need to do it over and over and over again. Not doing your homework to get the homework done, doing your homework to understand. So thinking about what you're doing, pondering the ideas, investigating why long multiplication works, why multiplying by 10 is moving the decimal place, or dividing by 10 is also moving the decimal place. Things like that. We don't want to, we learn it by rote in the beginning, but quickly some concept emerges when we actually practice and think about what we're doing. But if we just do homework to get the homework done and put it away, we're not giving ourselves a chance to have that concept start formulating in our heads. So I think it's really important that you practice. Really need to practice. I drew up something on my computer to help me explain the fundamental underpinnings of what fractions are. So I'm gonna see you again at my computer. This bar here represents one whole. So that's the entire thing, whatever we're talking about. Then below, we cut the whole into 2 equal pieces. So, and each piece is 1/2 of the whole thing, the whole entity. And then as we move on, we're cutting each half in half. So if you cut a half in half, you get each half of a half is a quarter. And there are 4 quarters in a whole. So you can look at this bar, the 4 quarters, and you can see it's the same size as this bar, which is the entire whole. And all we've done is cut it into 4 equal parts. Excuse me. And the 4 equal parts equate to the whole, or if you put them together, it's one entire whole. But notice each fourth is 1/2 of 1/2. You can see that here. It's hard to conceptualize, I guess, if you don't really understand yet. If you understand, you're just going, yeah, this is, move on, move on, move on. But I'm not going to move on because for those of you who don't understand, we really need to think about it. So it might be tough to grapple with, and my explanation is just droning on and on about the same thing. So it seems weird to have so much to say about something that is honestly so simple. Once you get it, it's simple. When you don't get it, I understand it's just hard and it feels like you're never going to understand, and all kinds of things creep into your mind. Doubt, self-doubt, there's just all kinds of things. You can do this because you already do it. You understand what half a pizza is. You probably understand what half a tank of gas is. You probably understand what half a gallon of milk is compared to a gallon of milk. So you're actually doing this, you're applying this concept when you think about those things in that way. So we just want to come to grips with the concept really well so that we can apply it to any object that we want. So I'm sorry to go on a little bit of a tangent there, but let's continue here. So here we have a quarter, and if we cut the quarter into halves, you can see that 1/4 is cut into halves. Each half would be 1/8. And you can think about it, 1/8 and 1/8 is 2/8. And if you reduce 2/8, you get 1/4. So 2/8 is 1/4. So I hope that makes sense. And also, I want you to also think mathematical computation wise. When you say half of a quarter, you're actually multiplying 1/4 by 1/2. And when you do that multiplication, you know that you multiply numerators and denominators. So the 1/2 times 1/4, the numerators, 1 times 1 is 1, and the denominators, 2 times 4 is 8. So you get 1/8. 1/2 times 1/4 is 1/8. And how many eighths are there in the whole? Well, there's 8 eighths in the whole, and you can see that there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Each one of them is 1/8. If you put them all together, they add up to 1. And you can see that in this picture. I hope that's making sense, because that really is all there is to it. But there's a caveat that applying this to situations isn't as apparent as what I'm describing here. I hope that what I'm describing here, you're just going, yeah. Yep, I get that. Yep, I get that. Yep, I get that. So, and that's sort of what I expect you to be saying, that you get it. But what we need to do is be able to apply it to situations. So, and I'm going to do that at the whiteboard in a couple minutes. So I hope you get this. And then I want to talk about what percent is a little bit too, because it's the same concept. It's just a different label. So with percent, we're always chopping. So here's the whole. This is the whole. And we're always chopping. I don't know what that is. I'm going to get rid of it. I hope I'm going to get rid of it. We're always, when we apply percent, we're chopping the whole into 100 equal pieces. Doesn't matter what whole you're talking about, what the whole is. It could be an apple, it could be a car. You can, in principle, you could apply it to anything. It doesn't even really have to be an object. It can be a concept of something as well. So, but that'll come with time when you understand. So back to my explanation. This is the entire whole, and if we chop the whole into 100 equal parts, each one of these boxes is 1/100th of the whole. So, and each piece, if you just looked at one individual 1/100th, that would be 1% of the whole. So each hundredth is 1%, and if you had 100 hundredths, or 100 or 100 1%, that would add up to the entire 100%. So 100 1% is 100%. I suspect that those of you who know what I'm talking about are just going, oh my God, how can he still be talking about this? Holy smokes. And those of you who don't know what I'm talking about or are still grappling with the concept are probably going, wow, this is all Greek to me. I don't know what he's saying. I don't know what he's talking about. It sounds like he's talking in circles. So I'm not talking in circles, but I am repeating myself. And I am saying the same thing in different ways over and over again. So I'm hoping that this is helpful, and I welcome questions. I hope this makes sense. I'll see you at the whiteboard. Thanks. Okay, so now we're going to do a couple fraction examples. So what I want to do is add together 1/3 plus 1/4. And I want to do that thinking of the boxes that I explained over by my computer, or with my computer. So 1/3, this is going to be one whole thing, and this is also going to be one whole thing. So that's one whole object, and that's one whole object. But we don't want the whole object. We want 1/3 of the object, and we want 1/4 of the object. So I'm going to draw another box underneath it, the same one, but I'm going to cut it into thirds. I'm going to do the same thing over here, the same one, but I'm going to cut it into fourths. So this is 1. 1/3 of 1 is just this one chunk, so it would be that much of that 1. So that's 1/3. I'll give it a little shading here. And same type of deal is going on over here. This is 1. We want 1/4 of that 1. So this is 1/4 of 1. You can see it's 1/4, and I'll shade that as well. So what we want to do is add 1/3 and 1/4. So we want to add this to that. Well, it's not readily apparent how to do that. I mean, because they're different size things. There's no real way that I can see to add those together. You just kind of say, well, it's some stuff. Is that stuff more than 1 or less than 1? Or is that stuff added together, is that more than one full unit or less than one full unit? Or more specifically, what exactly is it when you add it together? Well, in order to add it together, you need to look at it in terms of the same unit. So right now we're looking at thirds and fourths. That's not the same unit. So what we need is, it's called a common denominator, but what we're doing is chopping it up into the same type of unit so that we can add those units together, because we can add the same unit together, but different types of units we can't add together. That'll totally make sense as your understanding evolves, but for now you might just have to go with it, or hopefully it does make sense. I'm not sure where you're at actually. But the common denominator there is 12. So we could break up this 1 into twelfths. So there would be 12 things here. And we could break up this 1 into twelfths, and there would be 12 things here. And we choose 12 because that'll make this an exact number of twelfths, and this an exact number of twelfths. And I'm going to do that right now. So this would be like that. So that's 1, 2, 3, 4. There's 4 twelfths. Each one of those is a twelfth. You can see 4 of them there. There would be 4 of them there as well. Remember, this is a third, just like this is a third, just like this is a third. So if there's 4 twelfths there, there would be 4 twelfths there and 4 twelfths there. All in all, it'd be 12 twelfths, and 12 twelfths is 1. So, but we are adding 4 twelfths, or 1/3 is 4 twelfths. And we're going to do the same thing here. And that's going to be 1, 2, 3, 3 twelfths. So 3 twelfths is 1/4. There are 4 fourths here. Each one of them has 3 twelfths in it. So we had 3 twelfths and 3 twelfths and 3 twelfths and 3 twelfths. So all in all, there would be 12 twelfths, and 12 twelfths is 1. Now we can add the same types of units. So we're adding 4 twelfths plus 3 twelfths, and that's equal to, since we're adding the same types of units, we just can add the numerators. So 4 twelfths and 3 twelfths is 7 twelfths. So really hope that makes sense to you. You know, some people will say stuff like, well, how can we add the numerators and you don't add the denominators? And my response to that would be, you know, if you want to add the denominators, you know, think about, isn't 5 plus 3 equal to, isn't that the same thing as 5 over 1 plus 3 over 1? I mean, isn't 5 ones is 5, right? We learned that you can put it over 1 and it's the same thing. Do you want to add the numerators and denominators here? I mean, here it's clear that it's 8, right? There, 5 plus 3 is 8. Here, if you add numerators and denominators, you get 8 over 2, which reduces to 4, and that's not 5 plus 3. So I hope this makes it clear that you only add the numerators. In fact, when you're adding just integers together, there actually is a denominator of 1, but we don't write it because it's unnecessary. So we just write 5 as 5. We don't write it as 5 over 1. But we know that it is 5 over 1. So again, I'm really hoping that makes sense. And here's some things that happen in terms of pattern recognition. I've had students say, a friend at school explained it to me, and he said you just do this. You add these two together, and you put it in the numerator, and then you multiply these two together, and you put it in the denominator. And see, that works. So I was like, oh, okay. Well, what about this one? What about if you add 1/4 plus 1/8? That's equal to, by your method, or by the method I just described, that would be 12 30-seconds, which actually is the right number, but it's not reduced. This one was reduced So now you have to remember to reduce it. And if you understand common denominator, if you understand how fractions work, you're gonna recognize that. You're just gonna know that that needs to be reduced. You're not going to leave it like that. But if you don't understand fractions, then you run the risk of making a careless error. So this reduces to 3/8. If we had done it, and I want to mention that 32 is a common denominator. That is a common denominator between these two numbers, or these two denominators. But it's not the lowest common denominator. If we had worked with the lowest common denominator, we wouldn't need to reduce. So if we do it with the lowest common denominator, 1/4 is the same thing as 2/8. 1/8 is 1/8. We have the same denominator, so we add the numerators, keep the denominator, and we get 3/8, just like that. So that's an issue with just noticing a pattern and going with it. It's kind of like, well, it works, but when you investigate a little further, no, it doesn't work. And here's another example of where it doesn't work. What if we did 2/3 plus 1/4? I think I gave this example to that student, and that student just said, oh, well, it just would be 7/12. And he was perfectly happy with that explanation. He was perfectly happy just going, yep, 7/12, that's what it is. When I think it's, well, if you understand fractions at all, it's clear that it's not the same. It should be clear that, 1/4 is 1/4. 2/3 is not 1/3. If you add these two numbers together, it can't be the same thing as adding these two numbers together, but we got the same answer. So there's obviously a problem. This obviously isn't true. So we need to adjust our understanding, try to gain a deeper understanding of what's going on, and try to learn what's going to work and what's not going to work. That obviously doesn't work. So that's really, this is it. This is the stuff that you need to understand, and once you understand these principles, you'll be able to do fractions. There might be some weird stuff that goes on, but you'll be able to field questions and expand your understanding. So this really is where it's at. And now I kind of want to do something that will push our understanding a little bit. So now I'm going to try to challenge your envelope of understanding, or build on top of it, or expand it, deepen your understanding, or however you want to characterize it. But this is something that you might not have seen. So I'm going to do 60 miles per hour times 1 hour. And I'll just write this 1 hour as over 1. Then you can see that the hours cancel, and we would have gone 60 miles. So this is equal to 60 miles. Now I'm going to use the multiplicative identity, which is 1. We learn in some 3rd or 4th grade that the multiplicative identity is 1. When you multiply anything by 1, you don't change its value. When I first learned that, it seemed kind of useless. It seemed like a throwaway concept. As it turns out, that concept has implications, and we're going to take a look at one of the implications right now. So it's pretty obvious that if I multiply by 1, I haven't changed anything. Nothing changes. But I'm going to multiply by, I'm going to write 1 in a different way. Instead of multiplying by just 1, I'm going to multiply by 1 in this way. 2/3 times 3/2. That actually is 1, right? The 2's cancel and the 3's cancel. So this reduces to 1. And so we're just multiplying that by 1. So nothing changes. We've still gone 60 miles. So now I'm going to use the commutative and associative law of multiplication to change the order in which I actually multiply these. But you know that the commutative and associative law of multiplication means that it doesn't matter which order you multiply in, and it doesn't matter how you group the things that you're multiplying, the result doesn't change. So what I'm going to do is multiply, take this 3/2 and move it over here. So instead of doing that there, I'm going to take the 3/2 and multiply it here. And 3/2 times 2/3, that's still 1, so we're still just multiplying by 1. And now I'm going to use the associative law of multiplication. I'm going to group it like this. So now I'm going to see, I'm going to reduce this, I'm going to simplify that, and I'm going to simplify that. And we're going to see what happens. So 3 times 60 is 180. 180 divided by 2 is 90. So this turns into 90 miles per hour. And this turns into, it looks like it's going to be 2/3 of an hour. So 2/3 times 1 hour, that is 2/3 of an hour. And we already know that that's going to be the same, we only multiply by 1, so the result's still 60 miles. And, if you want to, you can go ahead and do the math here, and you'll see that it is 90 times 2 is 180. 180 divided by 3 is 60. So it still works. But notice what happens. We increased our speed by 1/2, and we decreased the time that it took to get there by 1/3. So notice the relationship there. If you increase your speed by 50%, then you reduce the time to destination by 1/3. Ask yourself, why does it happen that way? That's kind of weird that it happens, or the first time you realize that, it seems strange. But after you've done it a zillion times, you're like, oh, that's how it works. And you can use this to quickly figure things out or impress your friends, if your friends get impressed by stuff like this. I hope this makes sense, and I hope you're getting benefit from it. And again, thanks for spending the time listening. Take care.